Hey everyone, I'm sorry I can't be there in person today, but hopefully this video helps you understand the notes. As always, I do still want you guys to copy them down and kind of learn everything, but hopefully me talking through a few things will help you. You don't have to listen to every little detail of this. Feel free to skip ahead on certain parts, but it's always better, I know, to hear me talk about it than to just see it written down. So this first page today looks a lot similar or a lot like what we did last time. We're doing some more definitions. This time we're going to start looking at angles as a shape in geometry. Okay, so first couple definitions here. An angle actually has a definition in mathematics. And I had some trouble with people knowing what this was last year, so hopefully I do a better job this time. An angle is actually just a figure that's formed by two rays that have the same endpoint. So if I think about drawing an angle, I'm going to start with an endpoint. And oops, let's make that bigger. We'll start with a point here, and I'm going to call that point A. And then I'm going to make two rays from that same point, just going in slightly different directions so that they create an angle. So I draw a ray going that way, it would go on forever. I can then draw a ray going out this way, it would go on forever, right? And those two rays form us an angle. And this space that's kind of between these two rays here, that's the angle that we would measure or see, right? We could put angles together. I could put another line over here, right, like this, and form a triangle, right, by making that first angle. But the angle is actually kind of defined as that space that's in between those two rays. That's what we think of as the angle, okay? Okay, when we're naming an angle, there's a couple different ways we can name it. So one way is using that endpoint and then one point on each of the rays. So I'm going to put another point here on this ray to call that AB, and then I'll put a point on this ray. So we've got A ray AC. So then when I name this angle, I'm going to name it in order, but I'm always going to put this endpoint in the middle. Okay, that point always has to go in the middle. So I can name this angle, and we're going to use a little angle symbol, and I can call it angle BAC, or I could call it angle CAB, right? I can do it in any order. The important part is that A is in the middle, okay? If I did ABC, right, if I looked at A and then B and then C, that's a different angle. That means the center of the angle would be at B, okay? Okay, that point that we're talking about, A there, that actually has a name, not just the end point here, but that is called the vertex of the angle. You guys have heard that word before, used with parabolas and such, but that's also the vertex of an angle, right? A couple other things. The rays over here are the sides of the angles. Okay, so our two rays are called the sides of the angles. And then another thing just to kind of think about, if we're talking about points that are in here, right? Those are points that we would consider being in the interior of the angle. And if I was looking at points over here, that would be points on the exterior of the angle, right? So think of like an inside or an outside of that angle. Okay, if you're between the two rays, then that's the interior. If you're not, then that's the exterior. Okay. Okay, another way that I can name this angle is I can actually just call this angle A. Okay, and there's times where I can't use a single letter, and there's times where you can. If you had, for example, an angle like this, and that was point A, there's more than one angle in that picture. I have this angle here, I have an angle here, and then I have the whole angle there. So there's actually three angles in that picture that have a vertex of A. So in that case, I can't just name that angle angle A. But if I only have one angle, like in our picture we drew here, then I can just call it angle A. Okay, if you ever doubt yourself on that, then just use 3 letters and you're always safe. Okay. The other way that you will see angles named is sometimes you'll just see a number right here inside the angle, and then I can name this angle 2. Okay, so if you've got a number right there inside the angle, then you can just use the number to name the angle. Okay, these next 3 you've learned before, probably in like elementary or middle school, and that's an acute angle, a right angle, an obtuse angle, and sorry, there's actually 4, and a straight angle. Okay, an acute angle, hopefully we remember, means that it is smaller than 90 degrees, or it's between 0 and 90 degrees. So we're going to say, if I've got an angle that looks like this, right, that would be an acute angle. And a lot of times when we write the measure of an angle, okay, so when we talk about the length of a segment, right, we talked about that, we can also talk about the measure of an angle. So I have the object, the angle, and then for the number part, I'm going to talk about the measure of the angle. And so normally you'll see like something written like this to give you the measure of that angle. So if that angle is 30 degrees, then that means it's an acute angle because the measure of our angle, or the measure of angle A, is between 0 degrees and 90 degrees. Okay, now this can get a little bit confusing, just so you kind of see here. This and this, those are less than signs. Okay, that's for the inequality part. And then this one is our symbol for our angle. So sometimes if you're using less than signs, you'll see me make like a little curve on it like that. So that way I can tell the difference between the angle and the less than signs. Okay, so that is an acute angle. Then we've got a right angle. A right angle is equal to 90 degrees. So it's going to look like that, right? So now our measure of angle A is going to equal 90 degrees. And when we mark a right angle, oops, I should put my letter on here, sorry. Put my A there. When we mark a right angle in our pictures, we're going to always mark it with a little square that tells us in a picture that that is a right angle. So if you ever see a picture and that little square is there at an angle, then that means you know it's a right angle. All right, then we've got an obtuse angle. An obtuse angle is bigger than 90 degrees. All right, so now we've got our angle A here, and the measure of this one would be something bigger than 90, but it's going to be less than 180. So say 120 degrees. So my measure of angle A, oops, I should have put it the other way, sorry. I put our 90 degrees first. And our measure of angle A is bigger than 90, but it's smaller than 180 degrees. Okay. And then our last type of angle is called a straight angle. A straight angle is when the measurement is exactly 180 degrees. We call it a straight angle because technically it's just a line. But if I put a point right here in the middle and put A there, if I'm actually measuring this angle, that is 180 degrees, right? If you turn halfway around, you get 180 degrees. So the measure of angle A equals 180 degrees. Okay, acute, right, obtuse, straight. Okay, just like with segments, we can also have congruent angles. Congruent angles are angles that have equal measures. So if I have 2 different angles, and we'll draw a couple over here. We'll call this one angle A. And if I draw another one, we'll call this one angle B. If they have the same measure, then they're congruent. Or if they're congruent, then they have the same measure. So I can say that angle A is congruent to angle B, right? And then that would mean that I could say that the measure of angle A is equal to the measure of angle B. The way that we mark congruent angles, so if you remember with congruent segments, we marked them with the little tick marks. For congruent angles, we're going to mark them with arcs. So if I put an arc in that angle and then an arc in this angle, that means that they're the same measure, right? They're congruent. And kind of like we've seen before, if you have already one tick mark, you can use 2 tick marks. Same with the arcs. If you've already used one arc, if you need to mark another set, you could use a double arc. And we'll see that more as we draw some pictures. Okay, our next couple, adjacent angles. That word adjacent means next to, right? If you're standing adjacent to someone or a building or something, you're standing next to it. So adjacent angles are 2 angles in a plane that have a common vertex and a common side, but no common interior points. So really all that means is that it's 2 angles that are next to each other, but they have to share the same vertex. So for example, if I draw, oops, let's switch colors here. Say I draw an angle like this, right? And I put a vertex there. If I put another line here, right? And if I'm looking at our 2 angles here, let's give them some names. Let's just use numbers to make it a little easier. So we're going to call this one angle 2 and this one angle 3, right? So I can say that angle 2 is adjacent to angle 3. Right? They share a common vertex right there, right? They also share this side in the middle. That side is part of both angle 2 and it's part of angle 3. But their interiors are different. So the interior of angle 3 is there, the interior of angle 2 is there, right? That's kind of what all those words mean in your definition. Okay, adjacent just means next to. Okay, then an angle bisector is similar to like our midpoint or our segment bisector. An angle bisector is a ray that divides an angle into 2 congruent adjacent angles. So our picture is going to look similar to the last one, except this time it's going to split it right down the middle. So if I make myself one angle here, we'll do this one with letters just to kind of see how that one goes. And then if I draw a ray splitting that in half, then I've now created an angle bisector. Okay, so I'm going to put a few more points on here. Let's put B, and we'll put C over here, and let's call this X. Okay, so this ray, AX, is splitting our big angle into 2 smaller congruent angles. So we could say that ray AX bisects angle, and I want to say the big angle because it's cutting that big angle in half. So I'm going to use 3 letters and put my vertex in the middle. So I could say angle BAC. You could also call it angle CAB, right? And then because, again, that's an angle bisector, that means we could mark these 2 angles congruent. So that means this angle is the same as this angle. Now you'll notice I kind of stagger my arcs there, right? If I put them right next to each other, oops, I erased too much. Hold on. Just want to show you how this looks. So if I did an arc here and then another arc here, it's hard to tell that I actually marked the 2 angles separately. So I always take my second arc and I put it a little bit higher than the other one. That way I can tell they're marked separately. Okay, so angle bisector. Okay. So after our segment definitions, we talked about a ruler postulate and measuring segments. And with our angles, we get something very similar that's called a protractor postulate. It's basically the exact same thing. It's saying that if I have a protractor, I can put it down on my paper and find any 2 points and subtract and do the absolute value, and that would give me the measure of the angle. So for instance, in our picture here, we see this kind of X line here and Y there. So if I wanted to measure this angle, right, I could find, if this is X and this is Y degrees, right, I can subtract X and Y and take the absolute value, and that gives me this measure of this angle here. Okay, if you've not used a protractor before, that's kind of what we're going to practice a little bit today, just so you kind of get the idea of how it works. Okay, so down here on your paper, we've got a protractor printed for you. You don't need to have one. If we do this on a quiz or anything, I'll always kind of give you a picture like this so you can see how that works, okay? Okay, so I'm actually going to change one of these because on this, it says measure of angle O, right? But there's a problem with that. If I look at my picture here, at O, this point right here, there's 1, 2, 3, 4, 5, 6, 7. There's a lot of angles. I can count a whole bunch, right? So I can't call it a measure of angle O. There's too many angles there. So instead, we're going to call this, let's mark that out. Oops. Let's change this to the measure of angle AOE. Okay, we're going to give it 3 letters. That way we know where to go. So if I'm looking at AOE, well, I'm going to start at point A. I'm going to go over here to O, and then I'm going to go to E, right? And I think hopefully you can kind of see that means I'm looking for this measurement, right? So if I go over here, now on a protractor, notice you've got a set of numbers here, right? And then you've also got a set of numbers here. That's so you can start from either side of your protractor, okay? You have to decide which set of numbers you're going to use and stick to it. Don't use one from the top and one from the bottom. Make sure you're using 2 numbers from the same side. So for instance, over here, this is at 0 degrees, right? And then I took that from the top numbers. So I'm going to come over to E, look at my top numbers. This is at 180 degrees. So 180 minus 0, that gives us a measurement of 180 degrees. Hopefully, eventually, you don't need a protractor for that one, right? I know that that's a straight line, so it's going to be 180 degrees. But that's how you would see that on a protractor. Okay, let's look at the next one. Our next one says we want the measure of EOD, angle EOD. So again, this one tells me I'm going to start at E, right? And then I'm going to go over here to O, which is our center. And then I'm going to go to point D, which is up here. Okay, so now I'm looking for the measure of this angle. Sorry, my line's not right on there, but it's close. There we go. Okay, so I'm looking for the measure of that angle. So if I look at my 2 points here, E and D, well, E, and this time since I'm starting on this side, I'm going to use these inside numbers because it makes more sense to me at least to start here at 0 degrees. Okay, and then I'm going to go to my line here and count up. And sometimes we're a little bit off on these. As long as you're within a degree or 2 when you're using your protractor, that's fine. But I know that like this line is at 10, so this would be at 15, and then I go one more, so it seems like that's going to be at 16 degrees, right? So I just kind of counted these little tick marks. There would be 16 of them there. So since I went from 0 to 16, the measure of angle EOD is 16 degrees. Okay, let's try one more here. So our next one is EOC, right? So again, we're starting at point E. That's at our 0 degrees. And this time, though, I'm going to open up to point C. So now I'm looking for the measure of this angle, right? Now that C line kind of stops short of our protractor. So I'm going to do my best. If you got a straight edge, that might be helpful. Do my best to kind of extend that line as straight as I can. And then again, since I did 0 over here at E, I'm using these inside numbers. So I'm going to count all the way up, 10, 20, 30, 40, 50, 60, and then I go about halfway. So that's at 65. So that means the measure of this angle is 65 degrees. Okay. If you want to pause the video here and maybe try the other 3 on your own and then come back and see if you got them correct, feel free to do that. Otherwise, I will keep going here. Okay, so our next one is angle AOD. So notice we're starting at a different point this time. This time I want to start at A, which is over on this side, and then AOD is over here, right? So I'm going from this line A all the way over to this ray where our point D is. So I'm looking for the measure of that angle, right? This time I've got this line over here that's at the start. So there's our 0 degrees. So this time I'm going to use the outside numbers so I can count from 0 up. And then I'm going all the way around over here, get to 160, and then it looks like 1, 2, 3, 4 more. So that's at 164 degrees, right? So that angle would be 164 degrees. Okay, let's try another one. Okay, this next one, measure of angle 1. I know it's kind of hard to see, but here's our 1, right? So remember, if you have an angle named with a number, you're looking for that angle where that number is. So again, I can start here at A, which is at 0 degrees, and then I'm going to count up here. Looks like we go to about 26. So that's 26 degrees. Okay. All right, then our last one, if you tried this on your own, good for you. It's quite different than the rest, right? So this one, notice our starting point. Oh, wait, that's not what I wanted. That is, okay. Sorry, it's not that much different. So here's point B, and then here's point E. So I'm looking for the measure of this angle. Now, even though it said B first, I'm actually going to go over here and start at point E, because it is at our 0 point over here, and that's just easier. So then I'm going to use these inside numbers all the way around. We got to 150, 1, 2, 3, 4. So it looks like it's at about 154 degrees. Okay. All right, and then I actually want to do one more. Let's look at the measure of angle BOD. Okay. So if I look at that one, take off my green points here. Okay, so point B is over here and D is here, right? So we're looking for this angle. Now, there's several different ways you can go about this. The easiest way, I think, is to measure each one and then just subtract. So if I look at this point B, now again, the catch is here, I have to decide which numbers I'm using, outside or inside. It doesn't matter which ones. I'm going to choose to go with my outside numbers. So this one is at 26 degrees. And then if I go over here, I use my outside numbers, so I have to stay with my outside numbers. This is at 164, right? So then I can subtract those. If I do 164 minus 26, I get 138 degrees. Okay. Now, some people might choose to do this differently. I've had people before that instead they go with, oops, I'm gonna leave that on there for this angle. They go from E all the way around here and measure that. And let's see, if I did that, that's at 154. And then they measure just this angle, which is at 16 degrees, and then subtract that off, right? So whichever way works for you, either way you do it, whether you use the inside or outside numbers, you're going to get the same 138 degrees. Okay? All right. There's how we use our protractor in case you haven't used one before. All right, when we talked about segments, we had a segment addition postulate, which basically just meant if I have 2 points on a segment and another point in between them, I can add the 2 pieces together to get the whole thing. Same exact thing for an angle addition postulate. Okay, so with this picture here, I've got this small angle, I have this other small angle here, and then we have the whole thing. right? And notice I'm using a couple different lines because I don't know those are congruent or anything, but I know that I have those 3 different angles. But if I took this one and I added on this one, that gets me the whole thing, right? So it's the same idea, just instead of with segments, I'm looking at angles, okay? Notice in our little kind of postulate here, it talks about if D lies in the interior of angle ABC. So remember, here's my angle ABC. So that means I'm talking about this whole angle. And here is point D. It's on the interior of that angle. Okay. Then I can say, as long as D is on the interior of that, then that means that the measure of ABD, which would be this angle, right? ABD, plus the measure of CBD, so here's CBD, that's this angle, that would equal the measure of the whole thing if I add them together, okay? That D being on the interior is important because if I took this line off and I drew it over here and put point D there, then that theorem no longer works. It's different now because now ABD and CBD, it doesn't make as much sense for ABC. Okay, kind of think about that a little more if you need to, or we can talk about it more Friday. Okay, so let's try a couple with that theorem here and kind of see how that goes. Okay, so on our first one here, and this is just, we don't have any measurements, we're just going to kind of help us practice naming our angles too. So I want to do the measure of angle 1 plus the measure of angle 2, right? So here's angle 1 and here is angle 2. I'm looking at this angle plus this angle, right? If I add those two together, and actually let's try it this way too. Sometimes it's helpful to use like a highlighter color. So here's angle 1, and then we'll use another color. Here's angle 2. If I add those together, blue and pink make purple kind of, right? Then I would get this whole angle there, right? So we want to name this angle. So I know A is my vertex, so that's the letter that has to go in the middle. And then I'm using this ray and this ray to create that angle, right? So I could use my letter F up here, and then I could use B, or you can use C for the other letter. So that's going to be the measure of angle FAC. Or you could have BAF or FAB or CAF. Right? All of those will work as long as your A stays in the middle. Okay? So just looking for, when I add these two angles together, what bigger angle do I make? All right, let's try angle 3 is here and angle 4 is there. When we add those two together, we've got a vertex of F, and then we're going off this way and going off this way. So when I add those two measures together, I would get the measure of angle AFD or CFA, DFA, AFC. Any of those work. Okay, and then our last one, angle 5 plus angle 6. Well, here's angle 5, here's angle 6. Right? When I add those two together, D's in the middle, so there's our vertex. And then I'm going to go off this way and go off this way. So I'd have the measure of angle FDC, or CDF would work there as well. Okay. All right, let's try some with some numbers and see how this works. Okay, so we've got our picture here. This tells us if the measure of angle BCD is 2x plus 7 degrees. Okay, so let's look at angle BCD. Here's B, here's C, here's D, right? So if I follow those, that's this angle here. So the measure of this angle, and I like to write it in here, is 2x plus 7. Okay. Then we've got the measure of DCE, let's change colors here, is 3x minus 11. So here's DCE, so now we're looking at this angle. So that would be 3x minus 11. And then finally, it tells us that the measure of BCE is 76 degrees. Well, BCE, that's the whole thing. So the measure of this entire angle is 76 degrees, right? And then we know from our angle addition postulate, if I add the two small parts together, I get the whole thing. So we can set up 2x plus 7 degrees plus 3x minus 11 degrees should equal 76 degrees. And then we use our algebra to solve. So we'll get 5x minus 4 equals 76. Add the 4 to both sides, we get 5x equals 80. Divide by 5, we get x equals 16, right? Now notice on this problem, it tells us to find the measure of those two angles. All I did here was solve for x. So now I'm going to take my x and plug it back in to find the measure of each angle. So we've got the measure of angle BCD. Well, that was our 2x plus 7. So 2 times 16 plus 7 when I plug in 16 for my x. So the measure of angle BCD equals 32 plus 7, which is 39 degrees. That degrees symbol is really important. Eventually, maybe not on the very first quiz or anything, you're not going to lose a point, but on the test, you will lose a point if you don't use your degree symbols when you're talking about angles. So be careful. Okay, then our other one, the measure of angle DCE, we know is 3x minus 11. We're going to plug in 16 for our x. So then the measure of angle DCE would be 76. Oops, did I do that right? DCE, I wrote it wrong on my paper. Sorry. Yeah, no. I did something wrong there. Okay, well, when you work it out, you should get 37 degrees, right? And if you want to check your work here real quick, if I add these two together, you add those up, you get 76 degrees, right? And that's what we wanted the whole angle to be. Okay. All right. Our next one is very similar to the segment addition postulate, but it's special. It's a special version of the angle addition postulate, not segment. So angle addition postulate just tells us when they're next to each other, we add them up to get the whole thing, right? A linear pair is when you have two angles that are next to each other. They're adjacent angles, but they add up to 180 degrees. They make a straight angle. Okay, so our linear pair postulate is for straight angles. So a linear pair are two adjacent angles that make a straight angle. Okay, so this says if AOC is a straight angle, so AOC would be like this whole thing, right? It's a straight angle. And point B is any point not on AC, then the measure of AOB plus BOC equals 180. Right? Basically, we're adding them together to get that 180 degrees. So down here, for our example, we know that the measure of AOB is x. Well, AOB is here, so that'd be x degrees. And then angle BOC is 3x minus 4 degrees. Right? And then I don't need to be told the whole thing because I can see that's a straight line. So then I can add those together. X plus 3x minus 4 should equal 180 degrees. We get 4x minus 4. So 4x would equal 184, which means x equals 46. Now this problem just said, what's the value of x? I don't have to plug anything back in. I can stop there. There's my answer. Okay, so linear pair postulate is a special version of that angle addition postulate. It's just the angle addition postulate for straight angles. Okay, this next piece, this is actually on a page in your textbook, and I will talk about this a lot over the next couple of weeks. But in geometry, there are certain things that you're allowed to assume from a picture, and there are certain things that you're not allowed to assume from a picture. Okay, so if I look at this first picture here, it tells you over here what you're allowed to assume, right? All the points there are coplanar unless it tells you otherwise. I can tell that all of these things all meet here at B and they intersect there. You're allowed to assume that. A, B, and C are collinear. They're on the same line. B's between A and C. And then here's the big one that I have to usually remind people of. You are allowed to assume straight lines. Okay, so when I see this line here, it looks like a straight line, then it is. You don't have to get out a protractor and measure it or be told that that's a straight line. That's one of the things we're allowed to assume. Okay, if it's not a straight line, you'll be told, but you are allowed to assume straight lines. Okay, the other one, D is in the interior, and then adjacent angles. So I'm allowed to know that that angle is next to that angle. That's fine. So like I said, the big one here is the straight lines. I'm sorry, that won't color for me. Let's make it yellow, maybe. There it goes. Okay, you're allowed to assume lines. Okay. The next part is actually even more useful down here because this tells you what you're not allowed to assume. So in this picture, I will get all kinds of people that tell me, oh, look at this angle right here, that's a right angle. You are not allowed to assume right angles, okay? If it's marked, like in this picture, then I know it's a right angle. But if it's not marked, then I don't know it's a right angle. Okay, same thing with congruence, and we talked about this a little bit. It looks like B is a midpoint of that segment. If it's marked, like down here, right, I've got my two little congruent pieces, then I know B is a midpoint. But if it's not marked, it's not there, I don't know that B is a midpoint. Same thing with a segment bisector, right? It looks like these two angles here are the same. But I don't know that unless I'm told that. So if it's marked, like here, then I know they're congruent. But if it's not marked, I don't know that. Okay? Don't assume right angles or congruence unless you're told those things. Only one big thing you can assume are straight lines. Okay. Like I said, I'll say that a lot over the next couple weeks. Okay, this is more of our GCR practice. Again, if you'd like to pause the video here and kind of try this, since we tried it the other day, feel free to try it on your own, then come back and check your answers. I'm going to go through this fairly quickly, but if you've got questions on it, we'll go over this. So this one tells us that angle ABC is a right angle. Remember, your reasons over here are going to be our definitions or our postulates that we've learned. Well, this is talking about a right angle. I know that a right angle means it's 90 degrees, right? So if my given is that it's a right angle, then I can make the conclusion that the measure of angle ABC is equal to 90 degrees. And I can do that because I know the definition of a right angle. And feel free to abbreviate angle with the sign. Okay. The next one, this is telling me that two angles are congruent. Angle T is congruent to angle G. If I know two angles are congruent, that means that their measures are equal. So the measure of angle T is equal to the measure of angle G. And I know that because of the definition of congruent angles. Next one tells me the measure of angle QRS is 180 degrees. Well, if I know that the measure of an angle is 180 degrees, I know that that makes it a straight angle or a straight line, right? So I can say that angle QRS is a straight angle. Okay, and again, we know that because of the definition of straight angle. The next one, ray DJ bisects angle CDE. Well, an angle bisector cuts an angle into two congruent parts. This one might be helpful to draw a picture. So I'm going to come down here where I have a little extra room. I'm going to make my angle first. So if I make angle CDE, remember that point in the middle is my vertex. So D goes in the middle, and then here I'll put C, and here I'll put E. And then it says that ray DJ bisects it. So right down the middle, I make my ray there, and I'm going to put point J in the middle. So now I've got ray DJ going right through the middle of my big angle. And now it's easier to see the two congruent angles that it makes here, right? So I can say that angle CDJ, that's this one here, is congruent to angle JDE, which is this one here. Okay, it's a little easier to name those angles if you've got a picture to look at and see. And my reason for that is the definition of angle bisector. Okay, all right, then our last one, angle JKP and angle PKL are a linear pair. So remember, we said a linear pair means they're next to each other and then they make a straight angle. Okay, so if I know that they're a straight angle, then I know they add up to make 180 degrees. So I can say the measure of angle JKP plus the measure of angle PKL equals 180 degrees. And that comes from our linear pair postulate. Okay. So again, just kind of practicing. If I give you information, what conclusion can you make? What's the definition or postulate that tells us we can make that? All right, and that's it. A little bit longer today, lots of stuff all at once. Your homework tonight, notice, has two parts. We're doing both of the parts together this time. So you've got some book work to practice kind of the first part, and then you've also got a worksheet. The worksheet's really short. It's just to practice the protractor stuff. So all you're going to see on that worksheet is the protractor and the lines, and you're just practicing finding measures of angles using your protractor. Okay? Try what you can now if you have time, and then we will go through any questions when we have class next. See you later.